Hello everybody, welcome into another lesson. So today we are going to talk about graphing quadratic inequalities. Now, just like we graphed linear inequalities, you can also graph quadratic inequalities. So here you have y is greater than or equal to 3x squared. So if you have the equal to part, that means you draw a solid curve. Just like with linear inequalities, if you had the equal component, it's a solid line. Well, with the equal to part in the quadratic inequalities, it's a solid line. If it were just greater than with no equal to part, you would draw a dotted curve, indicating that the curve's not part of the solution. But since it's greater than or equal to, the curve itself is part of the solution. So let's go ahead here. We will then, what you have to do to graphically do this is you have to, in this case, since y is greater than or equal to 3x squared, you'll draw the parabola of 3x squared. Of course, identify the vertex. What would be the vertex? The vertex is definitely 0, 0, right? And then also the x-intercepts are at 0. And that's really all we can do. So, in fact, you would get 0, you would get the factor of 0, that x-intercept at 0 would be raised to the second power. So it would only touch the x-axis and not cross it. So you're going to graph your curve, the vertex at 0, 0, and then you have, let's pick some other points. What about at 1, you would get y at 3. If you pick 2, you would get y at 12, which would put you right about there. And then at -1, you would also get 3. -2, you would also get positive 12. So there's going to be your curve. It'll be a solid curve since you have the equal to component. And now we have to figure out the results for the greater than part. Well, the greater than part means it's actually above the curve. So you're going to shade everything above the curve to represent the greater than or equal to part. So that's exactly how you would graph this inequality of y is greater than or equal to 3x. Just shade the corresponding region, and there you have it. So pretty much proceed to graph this like you would a normal parabola, then shade the corresponding region. Get me an eraser here, that might help. There we go. And I got plenty more where that came from. Alright, I don't want to entirely destroy this, so I'm just rebuilding it a little bit. Okay, what if we had y is less than or equal to negative of x squared? So we got the inequality y is less than or equal to negative x squared. Well, since we have a negative coefficient on the x squared, that means it's actually going to be turned upside down, and it's going to fall to the left and fall to the right. But our vertex is still at 0, 0, right? The vertex would still be at 0, 0, And in fact, your x-intercept is also at 0, 0. But since that factor of 0 is raised to the second power, it's only going to touch the x-axis at 0, not cross. So let's go ahead and graph this here. Now, you have the equal to component, which means you'll have a solid parabola. So plot your vertex at 0, 0. Let's plot a couple of additional points. So at 1, when x is 1, you would get a y value of negative 1. When x is 2, you would get a y value of negative 4. And then likewise, when x is negative 1, you would get negative 1. And when x is negative 2, you would get negative 4. So now let's go ahead and draw this curve, the parabola. So we have a solid parabola. Now y is less than or equal to negative x squared. That means we're going to shade everything below the curve then, since it's less than or equal to. And the solidness indicates that the curve itself is part of the solution. So just shade everything below the curve here, below the parabola, and you'll have the area that you need to shade. All right. So you would shade that region underneath the parabola since y is less than or equal to negative x squared. I got plenty more. All right. This time we have y is greater than negative x squared plus 5. So we have y is greater than negative x squared plus 5. All right, so what we need to do now is first we just have greater than. There's no equal to component, so it's going to be a dotted parabola and not a fully closed parabola. So we know the coefficient on the x squared term is negative. So that means the parabola again is going to be turned upside down. It's going to, what it's going to do then is rise from, it's going to fall to the left and fall to the right. Well, the x-coordinate of your vertex is always what? Negative of b over 2a. Well, we don't have a b term because we don't have an x to the first term. So that goes to 0. But if you put in 0 for your for the value of x, you end up getting a y value of 5. So that means the vertex is at 0, 5. So that's always good to know. The vertex is at 0, 5. Now what about your x-intercepts? Well, we can sort of do that. If you take negative of x squared equals negative of 5, you would end up getting x squared equals square root of equals 5. Which means x would equal both plus and minus the square root of 5. So your x-intercepts are going to be at plus and minus square root of 5, 0. And the square root of 5 is a little bit more than 2. It's a little more than 2 in each direction. So let's draw a dotted parabola since y is just greater than negative x squared plus 5. So find your vertex, draw a little mini point there. We don't want to make it a big point because it's not equal. And then at negative square root of 5, 0, it's a little over 2, so right about there. And then positive square root of 5, 0, about right here. you'll end up getting something like this. You're going to get a dotted parabola. So I know it's weird whenever we have it dotted, but the dottedness means that the parabola itself is not part of the solution since it's just greater than. But we now want to find the region where y is greater than negative x squared plus 5. Well, that's going to be above this parabola line, so you're going to have a lot of shading to do. It's going to be everywhere above the parabola line. So, as you guessed, we have quite a mess here. Quite a mess of areas to shade. I think you get the idea of where I'm going with shading this, but I'm not going to literally color in the whole board, but you get the idea that literally it is everything above the parabola. So that would represent y is greater than negative x squared plus 5. Would be that whole region right there, above the parabola. Just let me erase some of this without completely destroying my board. All right. What's next? Y is less than x squared minus 3x. So y is less than x squared minus 3x. Well, first let's find the vertex. The vertex is what? It's always, the x-coordinate is negative of b over 2a, which in this case x would have to equal positive 3 over 2. So if x has a coordinate of 3/2, now, if I put in f of 3/2, what do I get? That would give me, of course, 9/4 minus 9/2, which would end up, of course, giving me 9/4 minus 18/2. Sorry, minus 18/4. So I get the value of my vertex being at the coordinate 3/2, negative 9/4. That's the coordinate of my vertex. Very important. Now, what about the x-intercepts? Well, we can factor x squared minus 3x. You would just get x times x minus 3 equals 0. Each of these factors is raised to the first power, so those are your x-intercepts, and the curve actually crosses the x-axis there. So the x-intercepts are going to occur at 0, 0, and then also at 3, 0. Those are your two x-intercepts. Now, since y is just less than x squared minus 3x, it's going to be a dotted parabola since the parabola is not part of the solution. And the coefficient on x squared is positive, so that means the parabola is going to open upward. It's going to rise to the left and rise to the right. So let's find our vertex of 3/2 negative 9/4. Let's plot that. So 3/2 is 1.5. Negative 9/4 is a little over negative 2 1/4. So right about there would be the vertex. We have an x-intercept at 0, 0, and again at 3, 0. So now you're going to connect everything, draw a dotted parabola going through those points. Alright, we got our dotted parabola since that's not going to be part of the solution. Now, we need to shade the region where y is less than x squared minus 3x. That's everything below the parabola. So get ready to do an awful lot of shading again. Everything below this parabola has got to be shaded, since it's just less than. And of course, as you get higher up, it's going to look like to the right of the parabola. It's basically everything outside the parabola would be shaded. And then, yeah, for good measure, let's do down here too, so you can really appreciate the solution to this. It's a hot mess. But graphing inequalities always has been a hot mess. And then around it, you can see the outline of that parabola that's kind of carved out in the middle of it. So it's everything below that parabola is the solution. I'm going to do about 5 more. We'll do 5 more. I know, it's a hot mess. Next lesson, we'll get into systems of quadratic inequalities. We'll be graphing those. Alright, what do we have next? Y is less than or equal to x squared plus 8x plus 16. So we have y is less than or equal to x squared plus 8x plus 16. So let's start by finding the x coordinate of the vertex. X is always equal to negative b over 2a, so that'd be negative 8 over 2 times a, that'd just be 2, which would be negative 4. So the x coordinate of the vertex is at negative 4. Now, if we take f of negative 4, that of course would end up giving us 16 minus 32 plus 16. Well, what do you know? You would get 0. So your vertex is going to occur at the coordinate negative 4, 0. Now what about your x-intercepts? Doesn't the x squared plus 8x plus 16, isn't that a perfect square trinomial? This would turn into x plus 4. That quantity squared is equal to 0. But since that factor is raised to the second power, yes, it's still an x-intercept, but it only touches the x-axis at that point. It does not cross. So what you're going to have then is you'll have the x-intercept would still be at negative 4, 0. So the vertex is also your x-intercept in this case. Now, the coefficient on the x squared term is positive, so the parabola will open upwards. And let's see. Yeah, that's all you have. And oh yeah, since you have the equal to component, you're going to draw a solid parabola. So let's find negative 4, 0. And then somewhere up in here it'll cross the y-axis. I'm not too worried about it. So there's roughly what your parabola is going to look like. And then what you need to do now then, y is less than or equal to x squared plus 8x plus 16. So solid parabola because the parabola is included because of the equality. But you're going to shade everything below the parabola because you're looking for the less than component. So we'll shade everything around it here. There's an awful lot of shading. If you aren't seeing it now, you're getting ready to see it. Everything below that parabola. And yeah, everything outside of it. See what a mess this is turning into? That's good for that. Let's do a little bit in the fourth quadrant here. I mean, good grief, this is a lot. So everything outside of the parabola will be shaded since that's part of the solution for the less than part. I have about 4 more. Again, my goal is to try not to destroy my entire axis, my entire coordinate plane. I'm trying not to destroy the entire thing. Goodness gracious. All right. Y is less than or equal to negative x squared plus x plus 6. So y is less than or equal to negative x squared plus x plus 6. Well, let's find the coordinate of your vertex. The x coordinate is always negative of b over 2a, so that'd be negative 1 over 2 times negative 1, which would be negative 2, which would give you a positive 1/2 x coordinate. If I take f of 1/2, what I get is, of course, what is 1/2? Negative 1/2 squared would give me negative 1/4 plus 1/2 plus 6, which is 12 halves, or even, dare I say, 24 fourths. It's 23 fourths plus 2 fourths, that'd be 25 fourths. So that would leave your vertex is going to end up being at the point 1/2 25 fourths. Kind of a hideous vertex. Now, what about your x-intercepts? Well, if I take negative of x squared plus x plus 6, set that equal to 0, I could factor out the negative, right? Which would end up giving me x squared minus x minus 6 equal to 0, which could factor into x minus 3 times x plus 2 equal to 0. I'll end up getting my x-intercepts at the point -2, 0, as well as at +3, 0. And since they're both odd factors, they're raised to an odd power to the first power, they're going to cross the x-axis there. So a couple things now. We notice that the sign on the x squared is negative, so that means the parabola is going to open downward, so falling to the left and falling to the right, as well as the fact that the since it's got the equal to component, it's going to be a solid parabola. So let's find our vertex, which is at 1/2 25 fourths, which would be a little over 6. That'd be 6 1/4 for the y. 6 1/4. So right about there is the vertex. All right, and then see, -2, 0 is an intercept. And then you have +3, 0 as an intercept. So that's what the solid parabola is going to look like. Now what we have to answer is, y is less than -x squared plus x plus 6. That means you'll shade everything below the parabola. So this time we don't have as much shading to do. It's just everything below this parabola. So inside the parabola, in other words. That's not going to be nearly as much work to do as what we've been doing. So that's the region you would shade, everything below the parabola. So that's the piece you would get. And I have about 3 more. All right. Y is greater than or equal to 2x squared minus 2x minus 5. So y is greater than or equal to 2x squared minus 2x minus 5. So the x-coordinate of your vertex is always the negative of b over 2a. So negative negative 2 is positive 2 over 2 times that 2 is 4. So the x-coordinate of the vertex is at 1/2. Now we have to find the y-coordinate. So 1/2 squared is what? That's simply going to be 1/4. Well, 2 times 1/4 is 1/2. So you'll have f of 1/2 would equal 1/2 minus 1 minus 5. So that'd be negative 1/2 minus 10/2. That'd be negative 11/2. So the vertex would be located at the point 1/2 negative 11/2. That would be your vertex, all right? Let's see if we could find x-intercepts. Well, this is definitely not factorable. But we almost don't need to know the x-intercepts, because what does this tell you, the sign on your quadratic inequality? It's positive, so that it's going to open upward. You have a vertex down in the 4th quadrant. It clearly has to cross the x-axis somewhere, right? Okay. And then you have the equal to component, so it's going to be opening upward. So yes, it is going to cross the x-axis at some point, unless you really want to sit there and do the quadratic formula and knock yourself out, but I don't think you do. So right about there is the vertex, and it's going to open upward. It's going to look something about like that. Now, we have to shade the region where y is greater than or equal to 2x squared minus 2x minus 5. That's going to be everything above the parabola. So again, this isn't too bad because it's inside the parabola where we're shading. So you're going to shade everything inside the parabola in this case. Let's see, I have, you know what? I think that's it. I think we get the idea. Next lesson, though, I would like to get into solving systems of quadratic equations. I would like to talk about that. Yeah, we'll do some quadratic equations. We'll solve some systems of quadratic equations. So, I hope everyone has a great day. Take care.